Okay, hi everyone. To save some time, I'm going to just try to record this, and we'll see how it goes. My first question for test number 4 was find the dy over dx in terms of x and y, which just means another way of saying derivative. So let's go ahead and just take the derivative here. We could solve for y first, but let's just take it as it is, and we'll do implicit differentiation, meaning we'll take it x's and y's as they are. So let's go take the derivative. That's going to be, we see x squared and y multiplying each other, so we have to use product rule. So I'm going to go take the derivative of the front, leave the back alone, derivative of the back, leave the front alone. Okay, the derivative of 4 being a constant, that's going to lead us to 0, and we're going to take the derivative of the right side, which is just 10x. We're going to solve for y prime. Goal is to solve y prime here. Get this guy alone. I'm going to move some stuff around and subtract the 8xy to both sides. Since these are not like terms, we can write them next to each other. And then we're going to divide that negative 4x squared to get y prime alone. And we're done. So our y prime is equal to 10x minus 8xy all over negative 4x squared. Okay, let's move on to our problem number 2. We want to take the second derivative here. So we have to take the first derivative followed by the second derivative. So let's go get started. The derivative of 5x is just 5. Derivative of negative y squared is going to be negative 2y followed by y prime for chain rule. And the derivative of 5 is 0. We're going to go ahead and solve for y prime by itself. Y prime is equal to 5 over negative 2y. Okay, we're going to take this derivative of this again for our second derivative. If you want, you can rewrite this, make this a little easier to look at. So when we take the derivative of this, we know that 5 over 2 is a constant. We're going to rewrite this as negative 5 over 2, and we're going to change y to the negative 1 power to right on top, so we can do power rule to it. So y double prime is equal to negative 5 over 2, because that doesn't change, that's a constant. And our power rule says it's going to be negative 1 y to the negative 2 power times y prime. In this case, yeah, y prime. Right. And we know what y prime is, so we're going to substitute that back in from over here. So we write as y double prime is equal to negative 5 over 2. Negative becomes a positive. See this negative here? Make that into positive 5 over 2. We're going to write y squared on the bottom. And we said y prime was going to be 5 over negative 2y. We're going to rewrite this all together as y double prime is equal to negative 25 over 4y cubed, because that negative 2 in the back multiplied by that 2 in the front gives me that negative 4, and we'll write that as an overall negative. Okay, let's move on to problem number 3. They want us to find the second derivative and given a point. So let's go ahead. This one seems pretty easy, straightforward. We take the derivative of 3y squared is 6y y prime, because of chain rule. The derivative of 3 is 0, and the derivative of 3x is just 3. Easy peasy. Now let's solve for y prime. We're going to get rid of the 6y to both sides. We can reduce that if you really want to. You don't need to, but I think it's going to make it a little easier. And then we're going to take the second derivative of this, easy peasy again. Y double prime is equal to 1 over 2. That's my constant. We can rewrite this over here as 1 over 2y to negative 1 power. Since it's a negative 1 power, we can then do power rule to it. So that's going to be a negative 1 y to negative 2, and then followed by y prime again. we're looking at specifically when x and y is this value here, 2, 1. So we're going to just plug in some values and see where that takes us. Our y double prime is equal to 1 over, let's get rid of the negative to the front, 1 over 2 y squared y prime, returning everything where it's at. We know that y, according to our given point, is a 1. So it's going to be negative 1 over 2 times 1. And our y prime, if we could plug in y prime, our y prime is this guy over here, where y is 1. So if we plug in y prime at y is equal to 1, it's going to be 1 over 2, and we said y was 1, right? Y is 1. That's 1 half. I'm going to plug in this 1 half here. I'm looking at negative 1 over 4. Okay, let's go ahead and move on to problem number 4. For each of the problems, we're going to look for the inverse function. Inverse at a. Remember that this a value here is really the y value because that's the inverse function. So this 4 here is really the y value. Remember, y is really f of x. So we're going to go ahead and we need to find our x value because remember, this identity, if I go and rewrite up here, is equal to 1 over f prime at our x value. In this case, that's going to be my x value. So we need to find the derivative of f, and we need to see f here, see f right there. And we're going to take the derivative of that, plugging in our x value. But we don't know what our x value is. So we have to go ahead and look for that right now. So let's go ahead and solve this. So 4 is equal to x squared plus 3. And again, we're trying to solve for our x value here. We're going to minus 3 to both sides, minus 3. Turns out x squared is equal to 1. Lucky for us, we're told that x is greater than 1. So instead of having two possibilities where we had to say plus and minus 1, x can only equal to 1. Okay, great. So now we have our b value. This is also our b value, right? So let's go ahead and finish our problem. I'm going to say f inverse of 4, okay, is equal to 1 over f prime of b, which is our x value, and our x value we said was 1. Now let's go and find what that derivative is. We see that that's our f function. So let's take the derivative. F prime is equal to 2x, and the derivative of 3 is a constant. And we're going to just go ahead and say f prime of 1 is equal to 2 times 1, which is just 2. And we're going to plug it in as 1 over 2. Easy peasy. We're just reading the instructions and remembering what to do. Okay. Okay, our same problem over here. Very similar. This problem just looks a little harder. We did a couple of these problems in class. So we're going to say f inverse, the derivative of that, of a, is equal to 1 over f prime of b, where remember this is my y and that's my x value. We're given a here, which is really a y value. So we're going to plug that into this value too so we can find x. So 2 is equal to 2x to the 7th plus 4x plus 2. We're going to solve for x. Minus 2 turns out that's 0. And here's our algebra 2 and algebra 1 skills coming together. How will this become 0? Well, we have a common value of x that we can factor out. 0 is equal to x. If I take out the x, we're left over with x to the 6. And since we took out the x over here, we're left with just a 4. So we can see that this for sure is a easy 0. But what about 2x to the 6 plus 4? Does that ever equal to 0? So if we try to solve for x, we're going to minus 4 to both sides, minus 4 to both sides. 2x to the 6 is equal to negative 4, and x to the 6 is equal to negative 2, and we realize that we can't take the cube root, no, sorry, not cube root, the 6th root, can't take the 6th root of a negative, so that leads us to a dead end. So this doesn't give us any real numbers. So our only answer here is x has to be 0. Okay, so now that we have our x and y value, where y was 2 and x is 0, okay, let's go ahead and fill out our identity. F inverse, the derivative of that of 2 is equal to 1 over f prime, so f prime at 0, but that's an x value. Let's go ahead and take the derivative. We're looking for f prime. F prime is equal to 14x to the 6 minus 4. F prime at 0 is equal to, we're going to plug in the 0. 14 times 0 minus 4 is just negative 4. Let's plug it back in. And that's 1 over negative 4. That's the answer, right there. Okay. There you go. Differentiate the function with respect to x. That's our next one. Okay. We have to remember. Okay, so let's go to write our identity. D over dx, a derivative of sine inverse of, let's call it u, is equal to 1 over the square root of 1 minus x squared, or sorry, u squared times u prime. Okay, chain rule. Let's be aware of that. Okay, so we're going to take the y prime here is equal to that exact identity, 1 over the square root of 1 minus, we're going to copy our inside values, followed by the derivative of the inside, right? This is my inside value. It's going to be 16x cubed. If you want to rewrite this, y prime is equal to 16x cubed over the square root of 1 minus 4x to the 4th power. And we're done. It's straight identities. Our tan inverse identity, d over dx of tangent inverse of u is equal to 1 over, remember this was a positive version, 1 plus u squared and then u prime because of the chain rule. Let's go ahead and take the derivative of this. Y prime is good. We just copy that identity. Remember the derivative of the outside is inverse tangent. So we take the derivative of inverse tangent is just 1 plus our inside value, copy, times the chain rule, which is 5x to the 4th power, power rule. Rewriting this if you want to is equal to 5x to the 4th power over 1 plus x to the 5th power. Okay. Let's move on. Okay, for each problem in the open interval where the function is increasing and decreasing. Okay, so we know that's a parabola because it's x squared, but let's say we didn't. We know that whenever we have a interval that's increasing and decreasing, that means we go from a slope that's either positive to negative or negative to positive. And in order to cross that, we're going to have to go through 0. Okay, so we're going to look for values where the derivative f prime is 0. So let's go ahead and find that. We're going to take the derivative of y. So y prime is equal to 2 times 2 is 4x minus 4. Let's go ahead and solve for 0. This happens when x, that's plus 4, 4x is equal to 4, x is equal to 1. So we're in one spot. And that's going to be my vertex also, turns out. Let's create a sign chart. We know that when x is 1, the derivative, y prime, is 0. Now what does it look like on the right side and left side? Let's go ahead and pick a number on the right side. We pick 2. Let's try 2. When we plug in, we always plug in back to our derivative formula here. So 2 times 4 is 8. 8 minus 4 is 4. That's a positive value. And again, if you pick any value to the right, if you try that with 3, 4, 5, and 6, that would all stay positive. On my left side, let's pick an easy number. We're going to pick 0 whenever we can. That's always an easy one. and 0 to the fourth power, no, 0 times 4 is 0, minus 4 is a negative 4. Turns out these are all going to be negative. So we know that the graph goes from a negative to a 0 to a positive slope. So that's going to give us a minimum, just FY. They were asked to restate the interval. So from negative, so we are decreasing between negative infinity to 1, and we are increasing from 1 to infinity. And again, we're making our intervals at infinity. These are open intervals because you can't ever really touch infinity. Okay, all right, easy peasy. Let's go ahead and do another one. Our next problem, similar. We don't know where this will flip from increasing decreasing, so let's go ahead and find the derivative. So y prime is equal to negative 3x squared because of power rule. We bring down the 2, that becomes a 6x. 2 minus 1 is a 1 power. We don't need to write that. And the derivative of 4 is 0, right? 0. And we don't need to write that either. We're going to make this go to 0. From algebra 1 and 2, we can factor out the x. Actually, let's factor out the negative 3 while we're at it, because they both have negative 3. We're left with the x minus 2. And you want to double check that. If you multiply that back over, you'll see that that's a 3x squared and a positive 6x. I'll make that go to 0, and this goes to 0 when x equals to 0, a freebie. That's my freebie. And when x is equal to 2. So draw my number line, where x is 0 and 2. And let's pick some numbers to figure out if this is increasing or decreasing. Okay, so let's pick a number greater than 2, that's a 3, 4, 5, 6, whatever one you want to do. And if I plug in that number into my derivative here, we'll see that it's going to be a negative. If I plug in a 3, this will be a negative. This will be a positive. Negative times a positive is going to be a negative. Oops. I mean negative. I mean negative. And then if I pick a number like 1, if I plug in 1 here, 1 and 1, that's going to be a negative and a negative, which leads us to be a positive. If you give me a number on the left side, let's say negative 1 or negative 3, it doesn't matter. That's going to be a, see, that's going to be a positive here, that's going to be a positive. And this is going to be a negative. So negative times a positive takes us back to being a negative. So we are decreasing, let's go ahead and write this out. We're decreasing in this section here and this section, but yet we're increasing in this middle section here. Okay. So we're, let's do increase, this is decreasing first. Decreasing from negative infinity to 0, and from 2 to infinity. And we're increasing from 0 to 2. Okay. So again, we're doing the same thing. We're looking for increase and decreasing, and sometimes we see a problem that looks a little bit weird. It's not an easy polynomial, but we just follow our rules. And the idea is that I need to find when this is increasing, decreasing, and that's all based on the derivative, just slope. So let's go ahead and see, how do we get slope? Well, that's just the derivative. I'm just going to go ahead and take the derivative. I see this is going to be a division, so I'll do quotient rule. So we're going to take, we'll take the negative with the top, okay? So we'll say derivative of the top, leave the bottom alone. minus the derivative of the bottom, which is just 2x. Leave the top alone, all over the bottom squared. Okay, we'll simplify that, we'll clean it up a little bit. So y prime is equal to negative x squared plus 16 minus a negative 2x times negative 1 becomes a positive 2x, all over x squared minus 16 squared. Okay, I'm going to rewrite that as negative x squared plus 2x plus 16 all over x squared minus 16 squared. Rewrite this again because I don't want the negative in the a value position. The front here, I don't like that too much. So negative x squared minus 2x minus 16 all over x squared minus 16 squared. So we're left with this funny looking quadratic there. And it's not factorable because all the numbers that make up 16 are 1, 16, and 2, and 8, and 4, and 4. And none of those actually subtract out to become 2. So let's go ahead and quickly try the quadratic formula and see what happens there. X equals to negative b, which is plus 2, plus and minus the square root of b squared, which is 4, minus 4ac. A and c is 1 and 16. So 4 times 64 is going to be 40, 64, and it's going to be a plus 64 all over 2a, which is just 2. Okay, sometimes we're left with a problem that looks a little funny to us, but we stick to our directions. The directions are looking for, hey, when is this increasing and decreasing, right? When is this increasing and decreasing? It's increasing, decreasing, and increasing, decreasing has to all do with the derivative. So we're just going to take the derivative and see where that takes us. So let's not overthink this. Y prime is equal to, I'm going to put the negative on top. So it's going to be negative 1, leave the bottom alone, minus derivative of the bottom, which is just 2x. And we're going to leave the top alone, which is just negative x, all over x squared minus 16 squared. Okay, we're going to simplify the top out, make it look a little prettier. This equals to negative x squared plus 16 plus 2x squared. I combine those together, over x squared minus 16 squared. Rewrite the top as just 2x, and then negative x becomes just x squared plus 16 all over x squared minus 16 squared. Okay. So we take a look at the problem and we notice that first the top section here, will this ever equal to 0? And x squared plus 16 equals to 0, minus 16, we end up taking a square root of a negative number, and we know that's not going to happen. So the top never gives us 0. So we don't have any critical points with zeros, but if you remember, critical points also happen when it's undefined. And if I look at the denominator, x plus 4 and x minus 4, these go to 0 at 4 and negative 4. Let's put that on negative 4 and 4. So we do have critical points, so we're going to have to test this. And actually, those are the points I need for my number line, to look at the slope. So let's pick a number in between. Well, we can pick 0 if I plug in 0. Usually I plug in 0. If I plug in 0, this will be 0. I'll be positive and a positive. We're going to be positive in the middle. The graph actually stops at positive 4 here. Stops here. So what's number bigger than 4? Let's pick 5. And if it's pick 5, it's going to be a positive on top and a positive on the bottom. So we know we're going to be positive here. And on the left side, I pick something on the left side here. Let's say negative 5. When I plug it in, all those squares become positive, and we're still positive here. So we're actually all increasing everywhere. So we're increasing everywhere except, let's write this in a way, increasing from, you don't need to write from, increasing from negative infinity to negative 4, then from negative 4 to 4, and then from 4 to infinity. And that's your answer. Okay. All right. Next problem. We're going to find the relative maxima and minimas. So we're going to look for whether the derivative is 0 and then check that the sign changes. On the AP Calc exam, you have to actually say that it's a maximum or minimum because the sign changes from a positive, negative, and negative, positive. So let's go ahead and take our derivative to find the slope there. So y prime is equal to 3x squared minus 6x. We set that equal to 0. But you know what? I'm going to take out a 3x to make factoring a little easier. I'm going to factor out 3x actually. We're left with an x minus 2. If you want to double check it, that's a 3x times x is 3x squared. And 3x times negative 2 is a negative 6x. And let's go ahead. So x has to be 0 and 2. Let's draw a number line for 0 and 2. If I plug in, let's pick a number that's greater than 2, 3. If I plugged in 3, let's go plug in 3 here just to see what happens. This is going to be positive and positive, right? So a positive times a positive means we're always going to be positive. So we're going to be positive here. If I plug in a number between 0 and 2, we'll plug in 1. All right, we'll plug in 1. If I plug in 1 here and 1 here, we see that's going to be a positive. And this is going to be a negative, right? So positive times a negative is a negative. If I pick a number over here, negative 1, we see that's going to be a negative and a negative. Negative times negative is a positive. So let's figure out which ones are a minimum maximum, relative minimum maximums. So this one over here is going to go positive slope, 0, negative slope. Negative slope, 0, positive slope. As you can tell, this is a max, and this is a min. And that's very colorful. Very colorful one. Okay, so we have a max at, let me not write it, so over there. Max at, when x is 0, but what's our y value? And we have a min at 2, but what's my y value? So where do we get these values from? Remember, we got to plug them back into my original function here. So let's go ahead and plug it in. I'm running out of space, so I'll write it down here in the bottom. What is f at 0 is equal to 0 cubed minus 3 times 0 squared plus 6, which is just 6. That's a 6. And f at 2 is 2 cubed minus 2 times 2 squared plus 6. That looks like it would be a bigger number, but as we multiply it out, that's 8 minus 8. Sorry, 8 minus 8. Oh, that's a 3, I'm sorry. 8 minus 12 plus 6 is 2. It's going to be 14 minus 12 is 2. So we have a relative maximum minimum. Okay, let's do the second problem. Okay, let's do the second problem. We're looking for max and min, so that has to deal with the derivative. Let's go ahead and just take that derivative is equal to, I don't like the way that looks. I'm going to rewrite this as a negative exponent, x squared minus 9 to the negative 1 power. I think that would be easier as a power rule. So it's going to be negative 1. We're left over with x squared minus 9, negative 2 power. Chain rule, which is just 2x. I know that looks a little messy. So it's going to be negative 2x all over x squared minus 9 squared. We have a couple of zeros here. So on top, we know we can make the top go to 0 if x is equal to 0. And the bottom, we can factor to be x plus 3 and an x minus 3. So we can say x doesn't exist at negative 3 and 3, which gives us, actually all these are critical points. So let's go ahead and draw a number line here. Oh, I'm running out of space. Let's not do it over there. So over here, number line. And we have 0, 3, and negative 3. And we'll see if we have any relative maximum minimums. Pick a number bigger than 3, let's say 4. I pick 4 here, 4, right? And maybe I'll pick 2 here, or 1, and negative 1, and negative 4. And as you plug these values in, we realize it's going to be a negative over a positive. The bottom will always be positive, so that's going to be negative. This is going to be negative, because this is going to be negative 4 on top. This is going to be a positive, and it's going to be positive. So we only have one point that's actually even considering a relative maximum here, because we're going to go up, stop, down. That's our max. Okay. And the sign changed from a positive to negative, so we have a relative max at when x is 0. Now if we know when x is 0, we don't know what the y value is, so let's go ahead and plug it back in. Let's plug this in right here. And if we're going to plug 0, we're going to be left with negative 1 over 9. Easy peasy. Okay, let's try to get this done. Sorry, it won't let me zoom anymore. Let's go ahead and zoom. Okay, we're looking for our absolutes. So that means we have to check not only our critical points, but also our endpoints. So let's go ahead and find the derivative. Y prime is equal to 3x squared minus 6x. We want to make that equal to 0. 3x, I'll factor out 3x because they both have a 3x to make my life a little easier. Minus 2. Double check, that's 3x squared and minus 6x. Make that go to 0. X is going to be 0 at 0 and 2. Parallel number line. And we know at 0 and 2, we have critical points. Now let's figure out which one's the min and our max. I mean, we could just plug them in, but let's go ahead and just do what we've been doing. If I pick a number bigger than 2, if I pick 3, maybe I'll pick 1 here, and I'll pick a negative 1. And it doesn't matter which one you pick, as long as you stay within those bounds. If I plug in 3, that's going to be a positive and positive. So we know we're going to be positive here. If I pick 1, here, you see this becomes a negative, right? So positive times negative is a negative. And if I plug in both negative 1, you see that's going to be both negative. And that's going to be positive. So we know for sure this is going to be relative. Max, because we went up, down, this is going to be a minimum. And let's go ahead and plug those values in. If I plug in 0, we end up with this being negative 2. Negative 2. Our minimum, plugging in 2 in. 2 times 2 times 2 is going to be 8. minus 2 times 2 is 4 minus 12 minus 2, and that's 14, so it's negative 6. So we see our max seems to be negative 2, but then, and our minimum is negative 6, kind of follows into place, but we have to also check our endpoints, and my endpoints are from 0 to 2. So that's it. Our maximum is going to be negative 2, and our minimum is going to be negative 6. And write that. Max is at 0, comma, negative 2, and our minimum is at 2, comma, negative 6. Okay. Okay, the next problem we're looking at here is just to the fourth power now. Should make this a little more tricky, right? Same problem. Y prime is equal to negative 4x cubed minus 4x. We're going to make this equal to 0. I can see a common negative 4. Oh, that's a positive 4, I'm sorry. So negative 4x, we're going to become x squared plus, oh sorry, minus, oh my bad. That's a minus 1. You can double check that. That becomes a 4x cubed and a positive 4x equals to 0. So x is 0 at 0. And when x can be plus or negative 1. So let's go ahead and draw my number line. And 0, 1, and negative 1. We'll plug it into my derivative. So plugging this all into here. And we're end up getting a negative here, what is it going to be, 0.5, it'll be a negative, and a negative, which is a positive. If I plug in negative 0.5, that's going to be a negative, and a positive is a negative, and this will be a positive. Okay. And our endpoints, let's double check, are going to be at 1 and at negative 2. So let's figure out what these values are going to be. We'll plug them back into my main function. So we're plugging the 1 into the problem. It will be f at 1 is going to be negative 1 plus 2 plus 1, which is 2. F at 0 is just 0 plus 0 plus 1, which is 1. F at negative 1 is negative 1 plus 2 plus 1, which I think we're back at 2. And f at negative 2, it's going to be a negative 2 times 2 times 2 times 2 is 16. And 2 times 2 is 4, so negative, positive 8 plus 1. That gives me negative 9, negative 7. So we can see that given all these possibilities, the max values are going to be at 2, and our minimum is going to be at 7. So this is our min, our max, and our max. And we can have more than one absolute max. With the same number, they just happen at 2 different places. Okay, here's our last problem. Same idea. We're just going to take the derivative. Don't overthink it. But we're going to rewrite it so it's 2 times x to the negative, x squared plus 1 to the negative 1 power. And y prime of that will be negative 2 x squared plus 1 to negative 2 power times 2x. Rewriting that to make it a little pretty, y prime will equal to negative 4x all over x squared plus 1. When will this ever become 0? When x is 0. See, that will make the top go to 0. And the bottom actually never becomes 0 because x, a positive plus a positive, is always positive. We actually have 1 point to check here. Let's take a look at my number line. X is 0. And if I look on the right side, we're going to have if I plug in like number 1, that becomes a negative value. If I plug in negative 1, this becomes a positive value. And we want to take a look at our boundaries now. Our boundaries are at negative 1 and 5. So now that we have our boundaries and our critical points, let's go ahead and plug in our boundaries and our critical point to figure out which one is the absolute max and min. So f at negative 1, my left boundary, we're going to plug it into, remember, this value here. So it will be 2 over negative 1 squared plus 1. And that's going to give us 2 over 2, which is just 1. We're going to plug in f at 0, which is 2 over 0 plus 1, which is 2. And we said that was going to be our max, so that looks pretty good for our max right now. And our right boundary, f at 5, which is going to be 2 over 25 plus 1 is equal to 2 over 26, which reduces to 1 over 13. Now if you look at these three values, which of these values look like they're the least? The 1, 2, or the 1 over 13? It turned out to be this guy right here. Right? So he's my minimum, and 2 is my maximum. So we write max is 0, 2, and our min is 5, 1 over 13. Okay. Last problem. Okay, we've been doing the same thing for min and maxes. We're taking the first derivative and looking for critical points and comparing those to the endpoints. If you notice something about this problem though, these points here is an open or closed interval. It is a open interval. So we're just going to use those for comparisons, but those cannot actually be our max and absolute max and absolute mins. So let's go ahead and do the same problem. Y prime, in this case, I'm going to have to use quotient rule. So it's derivative of the top, leave the bottom alone, minus derivative of the bottom, leave the top alone, all over the bottom squared. So we take the derivative of the top, leave the bottom alone, minus derivative of the bottom, leave the top alone, all over the bottom squared. Okay, and we're going to go ahead and simplify that. Y prime is equal to, multiplying that out, it's going to be 6x squared minus 12x minus 3x squared all over 3x minus 6 squared. We see like terms one more time. So y prime is equal to 3x squared minus 12x over 3x minus 6. I'm going to factor this out to make it look a little prettier by 3x. So we're left with x minus 4 over, let's do 3, sorry, that was a squared. 3x minus 6 squared. So we have zeros. X is 0 and 4. And we'll have a problem on the bottom when x is equal to 2. So we have a couple points we have to check, and we'll see how the signs are going to change. So let's draw my number line. We're at 0, 2 and 4. Let's also pay attention to my boundary points. I really only have to check the graph at 3 and 6. So I really don't care about what happens at 0 and 2. They're not my boundary. So if I'm going to go and check it, if I pick a number on the right side, if I pick in 5, for instance, if I plug in 5 into my derivative, that's going to stay positive. If I plug in 3 into my derivative, that's going to become negative. So we know we have a maximum, no, sorry, a minimum, right? A minimum at 4. Okay, so let's go ahead and plug in these values to see where they're at. Remember, this is a closed interval. We just want to make sure that this is the minimum, and it looks like that's the only minimum value because the endpoints on the right side is a positive slope to the right endpoint. That means there's going to be a maximum there, and on the left endpoint we have a negative slope, so that's going to be a maximum also. But that's just proved to you guys. If I write f at 3 on my left endpoint, f at 4 at my critical point, and f at 6, let's take a look here. So f at 3, that's going to be 9 over 9 minus 6. And that's going to be 9 over 3, which is just 3. If I plug in 4, it'll be 16 over 12 minus 6, which is 16 over 6, which gives me a fraction of 8 over 3. And if I plug in 6, it's going to be 36 over 18 minus 6, which is 36 over 12, which is a positive 3 also. So given these 3 points, 1, 2, 3, we know we have a minimum here for sure. And it turns out, remember, these are not included. So we can't even say that these are maximums. So we actually only have one answer here. So our minimum, our minimum is when x equals to 4 and my y is equal to 8 over 3. And we have no absolute maximums. Sorry, this is also absolute. That's so terrible. Absolute minimum. Alright, thank you. Good luck.